Now, in our today's lecture, we will study about how we can estimate the errors during any measurement. Now, the first one here is an absolute error. Now, what is absolute error? So, to find this type of absolute error, let us take one example. Suppose we are measuring any physical quantity like length, mass, time, etc. So let us consider any physical quantity and we want to measure that physical quantity. Suppose if any object is given and we want to find its length. Suppose the symbol of this length is A. So we want to determine the length A of this object. So what we will do? We will measure this length several times, because if we measure the length one time, then we cannot estimate the error. So if we'll measure the same length many times, then the chance of error will be less. And so suppose for the measurement of that length, we have taken the observations A1, A2, A3 and so on. Means we have measured the length how many times? One time, two time, three time and up to n times. You can measure any number of times. But as you increase the number of observation, the chance of reduction of error also increases. So it is better to take more observations. Now, after measuring these observations, it was found that all these observations were not same. Actually, we know that if I am measuring the length of this object, then its length is not going to change. The length of the object will remain same. But when I used to measure this length with the help of instrument, then first time the reading is different, second time it is different, third time it is different. So there is slight variation in the measurement. So what is to be done in such type of case? So in such type of case, we need to take the average reading. Now average of this observation means it is A bar. Suppose we have taken 3 observations. So first reading plus second reading plus suppose third reading. You can take more readings also. If more readings are taken, then that mean is to be taken or that average is to be taken. So here all the observation is to be added and it is divided by the total number of observations, and that will give you the average or the mean value of the measurement, and that mean value is the considered as a true value. Now after taking the mean value, we know that if that is considered as true value, then comparing that true value, that is A bar, comparing this true value with that individual observation, then we'll find that this observation will slightly deviate from the actual reading A bar. So that is nothing but the absolute error. So delta A1 is the absolute error in the measurement of first reading. And how we can obtain this? So mean reading minus first observation. then absolute error in the second reading. How we can find this? Once again, every time we have to take the true value, that is mean reading, and we have to subtract the observation taken. So minus A2 will give you second absolute error in observation 2, and so on. We can find the absolute error in the nth observation. Once again, mean, that is true value, minus the observed value or measured value. Now here this absolute error is always taken as positive. Here this answer you may get negative, sometimes you may get positive, but every time you have to consider it as positive only. Difference is always positive. So we will consider only magnitudes. You can see here, if I put this symbol, then this symbol says that it is a magnitude. Mod means the answer is always considered positive. So now, after obtaining all these absolute errors, again we will take the average of absolute errors, and so we will get average absolute error. Now how we can take the average of all these absolute errors? So once again, similar thing, add all these and then divide it by the number of observation. So as we have done in this, similarly we will do for this. We will add all these absolute errors by considering them positive only. See here, we have considered it as magnitude only, and after adding we will divide it by number of observation. Here n will be same as this, and so we will get the average of this absolute error also. Now after obtaining this true value and the error, we can now answer the final result. Hence the measurement of that physical quantity, suppose if this is length, then that length can be represented as its true value and plus or minus its average absolute error. Why it is plus or minus? Because in this true value, this much error can be plus, that is can be added to the true value, or can be subtracted from the true value, and that will give us the range of the measured value. Because if we use first plus, a plus delta a, then that will give you large value, and if we take a minus delta a, then that will give you minimum. So from larger value to smaller value, we will get the range of the measurement of a. Now after obtaining this final result by using the true value, that is mean value or average value, and the average of absolute error, we can find the relative or a fractional error. Now this is quite simple. Relative error means absolute error divided by true value. So absolute error divided by this true value is nothing but the fractional or the relative error. Now what will be the percentage error? So in this relative error, if you will multiply 100, you will get the answer in terms of percentage. So this is the percentage error. Simply multiply the fractional error by 100, the answer will be in percentage. So this is all about this absolute error, relative error and percentage error. Now students, let us see example number 2.6. This is only for your knowledge, means this type of things can be asked in short answers only. Here there are two clocks given which has to be tested against a standard clock which is located in a national laboratory. Standard clock gives exact accurate time, and at 12 o'clock in the noon the readings compared with the two clocks with the standard clock is given here in the table from Monday to Saturday. That means for 1 week the time of these two clocks were compared with the standard clock at exactly 12 o'clock noon. So on Monday it was found that the first clock shows the time 12 hour and 5 second. What is exact time? Actually it is 12 o'clock noon, because the standard time shows 12 o'clock, but here this first clock shows this much time and second clock shows this much time, 10 hour 15 minutes and 6 second, and so on. Every day this time shows in this way. And now after comparing this observed time for these two clocks, here we have to answer that which clock we should use during the measurement of time in any experiment. Here the precision is to be considered. So now students, you have to simply check the minimum and the maximum time of first clock as well as of the second clock for these 7 days. Now the minimum time for the first clock is this 11 hour 59 minutes and 15 second, and the maximum time which shows is this 12 hour 1 minute and 30 second. So if you will take the difference between this minimum and the maximum observation, then you will find that that difference is 162 second. You can check this two readings, you will easily find that the difference is 162 seconds. Sit with a rough notebook and a pen and also calculator and calculate this. You will find this as 162 second. Similarly, if you will observe the minimum and the maximum for second clock, then you will find this reading as the minimum reading and this reading as the maximum from these all observations. And if we will take the difference between these two, then we will find that that difference is 31 second. So now which clock gives minimum difference between the time? It is second clock, that is 31 second only, while here this first clock gives large difference. So during the experiment, which clock is good for the measurement? The one which gives small difference, that is considered as precise. And so, considering the precision, we have to use the second clock. Definitely, if you will see the time, 12 o'clock here and here 10. Standard clock also shows 12. So this can be considered as accurate, but this is not precise because the difference of the time is large from Monday to Saturday. Here this is not accurate, but this is more precise than first one. Now example number 2.7. What we want to find here? We want to find here absolute errors, relative error, or a percentage error. Now here this example is of the measurement of period of an oscillation of a simple pendulum. Students, what is simple pendulum that you might be knowing? Now a simple pendulum is constructed in this way. Take a thread, tie it at some support. This is a support. We are tying the one end of the thread at the support and the other end to a small solid sphere. Now what will happen if I disturb or apply some force to this sphere? Then it will start its oscillations. It will oscillate from point A to point B, and during this oscillation, suppose if it moves from point A to B and then once again back to point A, then time taken for this one oscillation is called as periodic time T. So here in this example, we want to estimate or measure the periodic time. So this is like an experiment. Once again, what is periodic time? Periodic time is the time for one complete oscillation. So here for this simple pendulum, 5 observations were taken. First time the periodic time came out to be 2.63 second. For the same simple pendulum, the periodic time measured for second time is 2.56 second. Third time it is this, fourth time it is this, and fifth time it is this. So these are the readings of periodic time for same simple pendulum. We know that the exact time of the period for the simple pendulum will be fixed. Its true value will be fixed, but when we measure during the experiment, due to some errors, the times are different. So error must be there, and if there is an error, we have to estimate that error. So now we will find that error only. So now let us start this solution. Here I have mentioned this times as T1, T2, T3, T4 and T5. Now to find the absolute error, what is our process? First we will take the average of this observation, that is average of these 5 periodic times. So how we can take the average? That we know. We have to add all the observations and to divide it by the number of observations. So number of observations are 5. So I have divided by 5 and I'll add these 5 observations here. So that will give you mean value or the average value of periodic time, and that can be considered as a true value. Now you can easily add these 5 observations with the help of calculator. So sit with your rough notebook and calculator. Just check that is it 13.12. If yes, then move forward, and now divide this addition with 5. You will get 2.624. So this is the average value, but generally we don't use the last digit. After decimal we use only 2 digits. And here one more reason why we are taking only 2 digits after decimal. It is because in the given readings also, you can see in all these given readings or the observations, after decimal point there are only 2 digits. And so in our answer also, for this mean value, there should be only 2 digits after decimal. So the mean value is obtained to be 2.62 second. Now this is the true value, and we want to obtain the absolute errors in each measurement. So to obtain these absolute errors in each measurement, we will subtract each observation from this true value, and whatever the answer is obtaining, that we will write in positive only, because when you will subtract each observation from t, you may get negative also, you may get positive also, but that difference which you have obtained by subtraction, you have to take it as positive. That is, only magnitude is considered. So now I'll show you for the first observation. What is t here? It is 2.62. This is true value, and from this if I'll subtract the first reading, that is 2.63, then what will be your answer? Your answer will be 0.01 second. We'll consider positive only. So difference of first observation with respect to this true value came out to be this much. Similarly, subtract second reading or second observation from the true value, you will get that as 0.06 second. Similarly, if you will subtract the third observation from this mean value, then you will get 0.20 second. For fourth reading it will be 0.09 second, and for fifth reading it will be 0.18 second. You can see here each and every difference is considered positive only, because these are absolute errors, and so only magnitudes are considered. Now after obtaining each absolute errors, what we will do? We will again take the average of these absolute errors. So taking the average of these readings, that is considered as delta t mean. So all this is to be added in the numerator and then dividing them by the number of observations. Addition of all these values gives out to be 0.54, and if we divide it by 5, then it will be 0.11 second. So this is the average absolute error denoted by delta t mean. You can write here mean or you can write here average. Meaning is same. Now finally, how you can answer about this periodic time? So the periodic time t of a simple pendulum can be represented as t is equal to, first we will write the true value and then the mean value of this absolute errors. True value was 2.62. I'll show you where it is. True value is this 2.62 and second value, that is average of absolute error, was 0.11 second, and hence the measurement of periodic time is this, that is true value, and this, that is error, absolute error. Now here in the measurement of this periodic time, in true value, this last digit, that is 2, is not certain, that is it is not significant, so we can remove that digit. Even in that average absolute error, here also this last digit, that is 1, is insignificant, means we can remove it, and so our final answer should be t is equal to 2.6 plus or minus zero point 0.1 second. And if I ask you what is the range of this periodic time, then range will be maximum to minimum, means 2.6 plus zero point 0.1 means it will be 2.7. So this is the maximum range, and if I want to find minimum, then 2.6 minus zero point 0.1, that will give you 2.5. So the range of the periodic time is 2.7 to 2.5. Now about relative error or fractional error. So it is quite simple. The symbol of this relative error is delta t. This is true value and this is the error. So average absolute error divided by true value, that is mean value of periodic time, gives us relative error. So use this 2.66 here and delta this 0.1 here and simply calculate it. You will get this answer in a calculator, but after decimal we will put only 2 digits, so we have to remove these 8. Now students, remember, when the digits which we are going to remove, if it is greater than 5, then definitely we have to increase this digit by 1. That means as it is 3, we will make it 4. So the relative error is 0.04. Now to obtain percentage error, it is quite simple. Whatever the relative error is obtained, multiply it by 100, then that will be in percentage. So if we'll multiply this 0.04 by 100, you will get 4. So percentage error is 4%. I hope you understood this example. If not, then once again watch this video. You will easily get it. Now about combination of errors. What happens if we add such two measured values? Suppose the first measured value is A and the second is B. And we know that when we measure any value, then there can be error. So here there will be an error in the measurement of A, as well as there can be an error in the measurement of B. So if we will add such physical quantities or such measurements, then the errors of this measurement will always added. So here, suppose the measurement obtained by addition of these two, A and B, the result obtained is Z. So even in this final result obtained by addition of A and B, the error in that final result, that is delta Z, is nothing but the summation of the errors of first measurement, that is A, and the second measurement B. Suppose if we are subtracting this A and B, in that case also the final result, its error gets added. There will not be minus sign. So while doing any mathematical operation, if there is addition or subtraction in the measured value, then in the final result the errors are always added. We will see multiplication, division and power later on. First we will see one example related to this. Now your textbook example 2.8 is about addition of two physical quantities. Here we are going to measure the temperature of two bodies, and suppose the temperature of the first body is came out to be 20 degrees Celsius plus or minus 0.5 degrees Celsius. Means here this is the true value and this is the error, average absolute error. Similarly, in the measurement of second reading, this is the true value, which is 50 degrees Celsius, and error in that measurement is 0.5 degrees Celsius. And here we want to find what is the difference in this measured temperature of two bodies. So when we take the difference, we will take higher value minus lower value. Which is large value here of temperature? It is 50 degrees Celsius, and this it is 20 degrees Celsius. So T2 minus T1. Now here we have written T2 and T1 which are given. T2 is this minus T1 is this. Now students, always remember, when we subtract, always the subtraction is carried out from true value to true value, that is 50 degrees Celsius minus 20, that is 50 minus 20 is 30. But here these two are the absolute errors, and so errors are always added, they are not subtracted. So 0.5 degree plus 0.5 degree gives 1 degree, and hence our final answer delta T is equal to 30 degrees Celsius plus or minus 1 degree Celsius.